Okay, so assignment 3 solutions that we'll discuss it here. Assignment 3 is on a finite differences. So in finite differences, the first question, the question number 1 is you are given this third degree polynomial, and the question is, yes, anyone remember that question? Anyone recall? Assignment 3. I show you that question. Okay, express this cubic polynomial in factorial notation and hence find fourth difference there. Okay, so that we have to do it. So the cubic polynomial is on the screen. This cubic polynomial we have to express in factorial notation. So as we know, already I told you should remember all these things. First factorial of x is x itself. Second factorial of x, yes, it is
x square minus x.
very good, x square minus x. Actually, it is x into x minus 1, but simplified you should remember. And third factorial of x should remember as
X cube minus 3x square plus 2x.
2x. Yeah, correct. X cube minus 3x square plus 2x, which is x into x minus 1 into x minus 2. So that's only here is done. So this polynomial, it is adjusted x square, x cube minus 3x square plus 2x is taken. So this x is taken extra. So minus x is written here. That is adjustment is done. So this first term become a third factorial of x, and x square minus x become a second factorial of x and minus 1. That's one. So simple. So we get the given polynomial fx. The given polynomial fx is third factorial of x plus second factorial of x minus 1. That is the correct answer. Now the first difference, delta fx. The delta fx will become 3x. See, here is this mistake. This x square is not inside. No? 3 second factorial of x plus 2 first factorial of x. That's okay. So these two should not be inside. So don't do these silly things. And
Yes,
second,
sir.
yes, second difference of fx, delta square fx is a 6fx plus 2. That is correct. Third is 6 and fourth is 0. That's one. Good. Other things are correct. Just a small silly mistake is there, that second factorial of x is written as x square there. That should not be there. I hope there should not be any doubt here.
No, sir.
No doubt. So let I show you the question number 2 then. Question number 2 is show that delta log fx is log of 1 plus delta fx upon fx. Okay, that we have to prove it here. Just there are three ways. One simple way is you can simplify LHS as well as RHS and show LHS equal to RHS, or you can start from LHS and come to the RHS. Both way you can go. So started with the delta log fx. Okay, so log of x, log of f of x plus h minus log of fx. That is also correct. So by property of logarithm, this is log of f of x plus h upon fx. That's good. Now f of x plus h. This is a log of, how it is written here. Okay, from here. So we know delta fx. This delta fx is f of x plus h minus fx. So the value of fx can be value of f of x plus h, value of f of x plus h can be written as delta fx plus fx. Correct. Very good. And that is replace only delta fx plus fx, separate division, and got the required answer. Good. That's correct. Nice. No doubt.
No, sir.
Come to the third. Third is a little different question, and many of students ask the doubts at the beginning because this type of the question you're not seen anywhere. The question is like this: show that delta of ux into vx is ux into delta vx plus v of x plus 1 into delta ux. Actually, this is known as the product rule of differences. Like product rule of differentiation, we have product rule for derivative. Similarly, we have the product rule for differences there. But here, by default, as h is not given, so it is assumed h equal to 1. So you can start for this question like let h is equal to 1. That is the starting line you can start. Good. Let h is 1. Then f of x plus h become f of x plus 1 minus fx. F of x plus 1 minus fx. That is, so now where you started, LHS or RHS? So something is the, I think not correct, is it? What is the meaning of this step? Can you explain, Yuvraj? Third step. That's not correct actually, I think. So from where we can start it here, this we can start with RHS also. Okay, if you have the problem with LHS, you can start with RHS. What is RHS? RHS is UX. So UX will be as it is. Let I write like this, UX. Delta Vx, yes, anyone? What should be the value? Delta Vx.
Vx plus 6.
Now plus Vx, v of x plus 1 is there, so as it is. And that delta Ux is u of x plus 1 minus Ux. Now, just we have to simplify this, and we have to check which term gets cancelled. Ux into Vx plus 1. Okay. This Ux into Vx plus 1, this term, this first term, Ux into Vx plus 1, will get cancelled with this Vx plus 1 minus Ux. Is that? The first and last term gets cancelled. I hope it is clear. So this is a minus ux vx, and this is that required. Now you got the answer. You will observe u of x plus 1. This term I am writing first. U of x plus 1, sorry, into v of x plus 1, that is this last term, minus ux vx. And what is this? This is actually delta of ux into vx only. That's the proof. Is that clear? Is that clear?
Yes, sir.
Okay, so it's so simple, just trivial proof is there. Just you have to start with RHS or LHS. But if you go with LHS, you have to adjust the term. So that is becomes little difficult. Means if you start with suppose LHS, this will be your first line for LHS. Next line will be this one. But after that, to get this step, you have to do some adjustment. So it becomes difficult. So better to start with RHS. We start with RHS for product rule as well as quotient rule of differences to prove it. Okay, that way you can prove this. So similar proof is there for quotient rule there. Okay, there is similar proof for the quotient rule. You can start with RHS better, I will tell you. I think whatever he written, this is not correct. This is not correct. Or whether he adjusted any terms there, it's not looking that well. So no, it's not correct there. The quotient rule, yes, this is the quotient rule of differences. So again, you can start with RHS and simplify it. You will get it. That's better. Okay, but you should get lastly. Yes, he started here properly again. That is okay. Now this is correct. Actually, he started with LHS only. Okay, so LHS is u of x plus 1 upon v of x plus 1 minus ux vx. This is correct. So this is the LHS because delta ux upon vx, and this is cross multiplied, and then some adjustment can be done, and this may be correct. This is okay. This is correct there. This way also you can proceed. Chances are very less to come these questions in exam, but I think this type of questions asked maybe 7 8 years before. uh, Come to the next question. Question number 4. Find the missing term. How many pairs were given in question 4? How many pairs of x and y given? Quick.
So 5.
No, 4 pairs given. No, third is missing.
Yes, sir.
4
4.
pairs given, so it should be a polynomial of degree
3.
3. So, and actually the question is missing term, but as missing term is there is no, you can say third difference is a constant or fourth difference is a 0. Okay, fourth difference is 0. So you can make a difference table, and fourth difference you will equate to the 0 because it is polynomial of degree 3. Fourth difference is equated to the 0, and a is a 31. That's the answer. I think it is a given. Yeah, correct. And lastly, we have to prove this operation. This we already done in the class. So that is very not completed, but you should do these equations, whatever given. So we have to prove del is equal to 1 minus 1 upon e. It is very straightforward. Just take a del fx, that is f of x plus h minus fx. Sorry, fx minus f of x minus h. And then how to write f of x minus h? Yes, anyone? So we start with like del fx, which is f of x minus fx minus f of x minus h. This is by del property. What is f of x minus h? Quick. What is the value of f of x minus h with respect to e? Shift operator.
E
E
raised to
raised
power
power
minus e
minus
f f
1
x
fx.
minus h.
Correct. And that's one. So it's 1 minus e raised to minus 1 of fx. So both are del fx equal to this of fx. So this implies operator should be equal. So 1 minus e raised to minus 1. And that's a required proof. That only we have to prove it. Del is 1 minus e raised to minus 1. E raised to minus 1 can be written as 1 upon e. So this is 1 minus 1 by e. Got it? Any doubt, anyone, in any of the question of the tutorial 3?